Hello everybody. So in this particular video I am going to tell about another important reaction which is already there in the organic chemistry, that is called Hofmann rearrangement reaction. Now the first question comes, what is the definition of Hofmann rearrangement reaction? So the answer is, when an unsubstituted amide is treated with an alkaline solution of bromine, or you may consider sodium hypobromite or chlorine, or you can say sodium hypochlorite, a primary amine with one carbon atom less is obtained. So this reaction is known as Hofmann rearrangement reaction. Now coming to the reaction scheme. So what is the reaction scheme of Hofmann rearrangement? You can see here. So here I have taken one amide compound. So this is the common structure of the amide, where you can see this R group, it may be alkyl or aryl group, whatever. So now once you add this bromine sodium hydroxide, so it will gives you a 1 degree amine compound. Now here you can see in the amide molecule how many carbon center is there, 1 2, but here once it will generate a amine compound, here you can see the number of carbon atom is less with respect to this amide. So this particular reaction is known as Hofmann rearrangement reaction. Now so when we talk about any organic reaction, the most important part of organic reaction is that the mechanism. So similarly you can see that if we talk about the mechanism of Hofmann rearrangement reaction, so it basically involves total 4 important steps. So step 1, step 2, step 3 and step 4. So now I am going to discuss about each and every step, how this particular amide gives you the primary amine. So coming to the step 1, here you can see that this amide undergoes base promoted bromination to give N-bromoamide intermediate. So here you can see this is the amide molecule, right? Now in the reagent we have taken bromine and sodium hydroxide. So initially what will happen? So this from sodium hydroxide it will gives you OH minus, right? So that OH minus, it can act as a nucleophile. So it will abstract one of the proton from NH2 unit which is present in the amide group, and it will gives you this a anionic charge, you can see. So this anionic charge is quite stable because it is conjugated with this carbonyl carbon, right? So now in the next step what will happen? This NH minus, it will attack over here in the bromine molecule, and ultimately it will generate a N-bromoamide intermediate. So this is the structure of N-bromoamide intermediate. Now here you can see so this intermediate, that N-bromoamide intermediate, it is also formed by using, you can see when sodium hydroxide treated with bromine, it will give you sodium oxy, what is the reagent? It is called sodium hypobromite. So it will gives you a sodium hypobromite, right? So now that sodium hypobromite, you can see that OBr minus, it will attack, it will abstract one of the proton from this amine NH2 group, amide NH2 group, and then it will gives you the final one, that is called N-bromoamide. Now after the generation or after the formation of N-bromoamide, so what is the next step? So step number 2 is the hydroxide ion abstract a proton from N-bromoamide to produce the corresponding anion. Here you can see this is the compound, that is N-bromoamide, right? So that OH minus, it will abstract one of the proton from here, and it will gives you this the corresponding anion. So this is the structure of this anion, right? Now coming to the step 3. So what is the step 3? So this N-bromoamide anion, so this is the N-bromoamide anion which undergoes migration of alkyl group. So that alkyl group, it will migrated from here to there in the nitrogen center, and it loses the bromine simultaneously and to gives isocyanate intermediate. So this is the intermediate that is called isocyanate intermediate, right? So this particular, this migration of alkyl group and as well as the losses of bromine, both the cases they took simultaneously. So that's why it is called concerted pathway, concerted reaction mechanism, right? Now coming to the last step, that is step 4. What will happen in the last step? So that once this isocyanate intermediate is formed, so that isocyanate intermediate undergoes rapid hydration to give an unstable carbamic acid. So this is the compound of carbamic acid and which is unstable and which is readily loses carbon dioxide to give the amine. So here you can see that isocyanate water molecule, it will attack here in this carbon center and it will give this kind of intermediate. Further this O minus, it will delocalize with this carbon nitrogen double bond and it will give this Rn minus COOH, this one. Now that N minus, it will abstract one of the proton from this water and it will gives you this carbamic acid intermediate and which is also quite less stable. So that from this carbamic acid you can see that OH minus, it will abstract this proton and it will gives you this RNH minus unit, and that RNH minus, it will abstract one of the proton from water and it will gives you the desired product that is called 1 degree amine, which is the number of carbon atom is less compared to the reagent. So this is all about the reaction mechanism of Hofmann rearrangement reaction. So thank you very much for watching.